We now go to another problem. That is, the problem says that body of mass 2 kg is lying on a rough inclined plane of inclination 30 degrees. Just draw this figure. Start with drawing a figure will be very helpful. The incline of 30 degrees. Mass of 2 kg is lying on it. So mass of 2 kg is lying on it. Says that its mass is 2 kg, right? This much is okay. Next he says, find the magnitude of the force parallel to the incline needed to make the block move upward the incline. That means, if I have to move this block up the incline, it will need certain amount of force. Let us say this force is F. The paper setter wants us to find out this force, that is F equal to how much? How much is the value of it? As usual, as I have indicated to you earlier, in all such cases, you first draw the force diagram. This is the line of force mg, and mg has a component perpendicular to the incline, which is mg cos theta. It has a force parallel to the incline downward, which is mg sin theta. And since we are trying to pull it upward, so there will be also a force, since we are trying to pull it upward, this force will be downward. There will be a downward frictional force. Since we are trying to pull it upward, there will be downward frictional force F. Just now have to play with these few forces. Now, let's not forget, there is a reaction force R. R will be equal to mg cos theta, right? So first we start from here. Mg equal to mg cos theta. N is equal to 2 kg. G equal to 10 into cos theta. Since it is 30 degrees, cos theta is equal to, it is equal to 10 root 3. 10 root 3 is equal to 0.3. So the reaction force R is 17.32 Newton. Also, let us find out the frictional force F. Frictional force F is equal to, we know, R. Mu is given as 0.2 in the sum, problem sum. So mu is 0.2. 0.2 multiplied by R is 17.32. 17.32. This is equal to, if you calculate, 3.464. So two forces we have already received. One is reaction force, another is the downward frictional force. Now consider, since we are trying to pull it upward, since, let us write upward, along the slope. This is important. Along the slope. So if we are trying to put the body upward along the slope, so then we have to only equate the forces which are along the slope. Now forces along the slope, upward force is F and upward force is F and downward force is mg sine theta, mg plus small f, the frictional force. So when this F will be just equal to mg sine theta plus F, that means they are equal, the force F will start pulling it upward. And that is what they want to know. Find the magnitude of the force, just the amount of the force needed to make the block move up. This is equal to mg sine theta plus F. If you calculate, m is 2, G is 20, G is 10, so it makes 20. Sine theta is half, and plus Fs is 3.464. 3.64. This F will be equal to 13.4. So this is one of your answers. The amount of force needed to pull the block upward. Now for downward motion. Let us first check the downward motion. Or downward motion, they want us to find out what is the force required parallel to the block to move it downward. That means if I have to move it downward, then how much force F dash say I have to apply? Yeah. What we find that downward gravitational force of the block on the block on is mg sine theta is equal to mg sine theta, and mg sine theta is equal to, get calculated here, calculated it here, mg sine theta is equal to 10 Newton. And, and optional force is 64 Newton. From here, upward frictional 0.464 Newton. That means downward gravitational force is much more than the maximum upward frictional force. So the flip downward by itself. So body will slip downward by itself. That means it will not need any additional downward force. No additional force. So this is the second answer. That means how much additional force is required to bring it downward? No additional force is required. Next part of the question says, repeat part A. That means how much force is required to pull it upward if the push is applied horizontally. Now look here, the push is applied along the slope upward. Now if the push is applied horizontally, then what happens? We have to let's draw the diagram once again. Let's draw the diagram, only part of the diagram once again. This is the body. This is the body. And this is mg, downward gravity, and normal gravitational force is mg cos theta. Parallel gravitational force is mg sin theta. Right? Now it is saying this force upward, this force is applied horizontally. That means a force is now applied horizontally. Something new. This is the force F applied. Earlier it was applied along the incline, now it is applied horizontally. It is applied horizontally. What we need to do, find out the vertical component of the force. This is the vertical, this is the component of the force along upward, along the incline, and this is capital F theta. If this is theta, then this angle is also theta, and this angle is also theta. And this force will have a component in this direction, that is F sine theta. That is F sine theta. Obviously, the force F sine theta does not have any contribution to pull it upward. Only F cos theta part contributes to pull the body upward. Now here, the catch of the question is the reaction force R will change. Earlier, reaction force R was equal to mg cos theta, but now reaction for R is mg cos theta plus F sine theta. These are the two things. Here, reaction force R is equal to mg cos theta plus capital F sine theta, plus capital F sine theta. This is equal to capital F is, we have to now find out, sine theta is half, plus m is 2 kg, g is 10, cos theta is √3/2. This becomes 8/2 plus 10/3. 8/2 plus 10/3. This is the reaction force. Then what is the frictional force is equal to frictional force is mu1. Mu is now given to be 0.2. That is 1.5. That is 0.2 multiplied by f by 2 plus 10 root 3. This becomes f by 10 plus 2. So this is the frictional force. Now we equate the horizontal forces. If we equate the horizontal forces, then this upward force capital F cos theta will be equal to mg sine theta, the component of the gravitational force, plus the frictional force Fs, which is acting now down. So here we find mg sine theta plus Fs will be equal to capital F cos theta. From here we find m is equal to 2, g equal to 10, sine theta is half, plus Fs, plus Fs we have got already. Fs is this much, capital F by 10 plus 2 root 3 plus capital F by 10 plus 2 root 3. This will be equal to capital F cos theta is root 3. If you deduct this, I don't want to really waste time by showing you the deduction. This you can do at home. If you deduct this, you will find capital F is equal to 17.58 Newton. Look at this. If you put the force along the incline, then you need 13.464 Newton. But if you put the force horizontally, obviously you will need more force, and that value is 17.58 Newton. So we stop here and we should go to the next problem.